going to do is we're going to go over antiderivatives and the indefinite integration rules. All right, how this is going to work is we're going to go over 5.1 today, and we're going to review for 5.1. You have a test on 5.1. Very simple concept. This will take about a week real time, so a little bit longer virtually. What you're going to be able to do at the end of this is write a general solution for a differential equation. Use indefinite integral notations for antiderivatives. Be able to use integration rules to find antiderivatives, and you're going to be able to find a particular solution of a differential equation. All right, the goal is by the end of today, or as long as you take to watch this, you'll be able to do all 4 of those things. First thing, what is an antiderivative? Well, it's known as f prime x. That little mark there is prime. Remember that from finding derivatives. Antiderivative is what it says. You're going backwards. Instead of going from f of x, taking a function and finding the derivative of it, you're going to take the derivative and find what the original function was. All right. The way it works is theorem 5.1 says the representation of an antiderivative, if f, that's the function, is an antiderivative of the original function, little f, on the interval I, then g is an antiderivative of the same function f on the interval I, and only g is of the form f of x plus c for all x, in which c is a constant. So what all this pretty much means is once you do find the integral, which is the antiderivative, so when you're going backwards from derivative, you have to add a constant on, because remember what was the derivative of a constant is 0. So you don't know what that constant is, but we're going to show you how to find out. Well, I'm going to show you how to find out. So here's how you find a differential equation. The general solution of the equation is y prime, or the derivative of an equation, equals 2. What function do you guys know of that has a derivative of 2? So when I point to you, try to answer it. So the derivative of what equals 2? That's what it's asking. Well, if you would have said, so since your derivative is 2, your original function would have been 2x, right? Because the derivative of x is 1, 2 times 1 is 2. So the derivative of 2x is 2, so the antiderivative of 2 is 2x. But are there any other problems where you could take the derivative of that give you 2 as an answer? I want you to think about that real quick. Yell one out real quick. Good. If you would have said 2x plus 7, you would have been correct. Derivative of 2x is 2. Derivative of 7 is 0. So the derivative of 2x plus 7 is also 2. Both have the same answer. Can you think of one more? If you said 2x minus 10, that'd be amazing, because what are the odds of that? But you'd also be correct. Now, it doesn't matter actually what number you put here, because 2x plus or minus any number gives you the derivative of 2, right? So instead of putting every single number, which is an infinite number of numbers, you can put a billion, a trillion, a gazillion, negative 500 over 3, pi, you can put anything you want. You just put a constant, which is c. So that's where you get y equals 2x plus c. All right, and don't forget, this is the biggest mistake a lot of people make, a lot of students make, a lot of adults make. They forget to add on the constant in the end. So you really do need that. We'll be able to find out what the actual number is later on if you're given a point. But for now, the basic antiderivative, we just leave it as plus c. Got it? Oh, hopefully got it. All right, so the derivative of c, think back to our rules, is 0. And that's the whole reason why this all works. Got it? Awesome. All right, let's move on to the next. Basic integration rules. This symbol right here means integral or antiderivative, okay? So when you take the integral of something that was derived, it gives you f of x plus c. Notice there's no longer a prime here. All right, very simple. The derivative of an integral, say you're using, the derivative of an integral is just like if you took half of 2, or if you took 7 times 1/7, okay? They cancel each other out. 4 minus 4, all right? So it's just f of x. So when you integrate a derivative, it's f of x plus c, because we don't know what the constant is. But if you derive the integral, it's just f of x, all right? So one ends to c, one doesn't. We're going to be dealing with that thing. So let's look at some basic rules and see if you can come up with these on your own. It's a little tough to do on the computer, but integral of 3x. So what we think of in our head is, what number 3x. All right. 3x is the derivative, so that's your answer. So what number did we start with? So work your way backwards. So what you can do is you pull out the constant. That makes it easy. What is the integral of x? So the integral of what gives you x? Do you guys remember? Well, I'm going to help you out if you don't. What is the derivative of x squared? Just yell your answers. 2x, right? Okay, but we need to make it an x. So how do you get 2x to be an x? You take half of it. So what's the derivative of 1/2 x squared? 1/2 times 2x, which is x. So the integral of x is 1/2 x squared plus c. And you still have your constant multiplied by. So we know that the derivative of this equals this. So the integral, you go backwards. You go from the derivative to what you're finding the derivative of. All right? 3 times 1/2 is 3/2. Duh. All right? X squared, and then don't forget your plus c. You don't need to distribute the 3 times c, because c is any number. Because 3 times any number is still any number, so it's kind of redundant. You just really have to multiply it by all the functions, not the c. So why don't you guys try problem 3? Go. All right, let's see if you did it right. Very similar. You pull the 5 out, right? Now, interesting. What do we got here? Same concept, right? X, always the integral of x is 1/2 x squared plus c. 2 times 1/2 is 1. This becomes an x. All right, so 5 times 1/2 is 5/2 x squared plus c. Is that really that difficult? Not at all. Why don't you guys attempt problem number 4? 6x squared dx. Go. It's a little different now. You're not going to have the integral of x. You're going to pull out the 6 and it's going to be 6 the integral of x squared. You guys are going to come up with the formula after this too. All right, you got it? So, derivative of what gives you x squared? Well, if you said derivative of x cubed, x to the 3rd power, you're close. This is 3x squared. Not exactly. We need to be x squared. So how do we get rid of this 3? 1/3. 1/3 of x cubed. All right. That becomes 1/3 times 3x squared. 1/3 of 3 is indeed x squared. So this would be 6 times 1/3 x cubed plus c. 6 divided by 3 is 2. 2x to the 3rd plus c. There you go. That is all you really have to do. And I'm going to give you a formula that's going to make it a lot easier. Can anyone think of the relationship between these things yet? 6x squared, 2x third, 5x squared, or at least between the variables. X squared, x cubed. Think. All right, let's look. Let's go over some basic integration rules. Now, we said before the derivative of c is 0, right? Derivative constant 0. What do you think the integral of 0 is? C, right? That was easy. The derivative of a number times x is that number, right? Integral of a number times x is k. You add the x on plus c. Going backwards. Derivative of k times a function is k times the derivative of that function, right? So the integral of k times a function is, what do you think? Going backwards. K times the integral of that function. We just did that one. All right, and you're going to understand what all this stuff means in a moment, don't worry. Derivative of two functions adding or subtracting by each other equals, you take the derivative of each one. Integral rule is the same. Integral of two numbers, addition or subtraction by each other, you just integrate each one individually. All right. Derivative of e to the x is e to the x. What do you think the integral of e to the x is? Not e to the x. It is e to the x plus c. Don't forget your c's. Whoops. The derivative of ln x, natural log x, is 1 over x. So what do you think the integral of 1 over x is? Ln x plus c. Just flip it, right? All right, trig functions. I'm going to bust through all these easy ones right now. If the derivative of sine is cosine, the integral of cosine is sine x plus c. Derivative of cosine x equals negative sine x. So what do you think the integral of sine x dx is? And the reason you have these dx's here, this just means you're integrating it in terms of x. All right, that's why all these things match up. If they don't match up, you're going to have to do some integration rules to fix it. All right, got an answer here? And you need the dx here to integrate it. Without a dx, you don't know what you're integrating in terms of. We'll get that later on. Negative cosine x. So it's a little different. It's cosine, sine, you still switch the two, but the negative is for the sine, not the cosine. If the derivative of tan x is secant squared x, what's the integral of secant squared x? Tan x plus c. Secant tan. Integral would be secant x plus c. Cotangent x equals negative cosecant squared x. Therefore, the integral of cosecant squared x is negative cotangent x plus c. Derivative of cosecant is negative cosecant x cotangent x. Go backwards. Negative cosecant x plus c. See? Opposites. 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 It's not really doing the opposite. It's just more of like an inverse opposite mixture type thing. Right? Power rule. This is the rule where you'll be doing most of your work, okay? Do you remember it for the differentiation formula? Write it down if you remember it. Derivative of x to the n. When you write it to a power, take that power, put it forward, and then subtract that power minus 1. Therefore, the derivative of x to the fourth was 4 to the x to the 4 minus 1, which is 4x cubed. You guys remember that. You spent so much time on it, you should. Integration formula. Going to do opposites. So how do you think this works? What's the inverse of n? 1 over n. What's the opposite of n minus 1? N plus 1. So it's x to the n plus 1. Instead of times n, it is divided by n. But you also have to add a 1 to it. Okay? Now let me show you how this works. Because we're doing the opposites. X to the fourth. Let's use our formula. 4 plus 1 is 5. 4 plus 1 is 5. Oh, plus c. Oh, I just forgot the plus c. All right, so n can't equal what? Obviously negative 1. X to the 4 plus 1 over 4 plus 1. X to the fifth plus c. X to the fifth plus 5 over c. All right? There you go. That's it. Now, reason you have to do the fifth is because when you multiply, if I did the differential formula to this, this would be 5 times this, and the 5 divided by 5 would cancel out. 5 minus 1 is 4. All right, so that's why you have the plus 1 on bottom. But if you just remember this formula right here, you're set. Now let's do a bunch of examples to make sure that you got this. This is easy stuff. I used to make this a bunch of, combine this in with tests, but I like doing it by itself now. It's a little bit better. So there are 4 simple steps. Well, there's really only 3. First step, what do you think that is? What are these things called? These things are all the integrals. We're going to integrate all those. Those are the original functions. So when you integrate these, before you integrate these, what do you want to do? The same thing you did with derivatives. And the first step with doing derivatives is always 2, because with an R, E, W. Rewrite. You're going to rewrite the equation. All right? So since this is in the denominator, that becomes x to the, jumped ahead. After you write it, you integrate it, and after you integrate it, you simplify. So let's do these steps. Integral of x to the negative 3. All right, anytime you have a thing on bottom, function on bottom, raised to a power, that power becomes negative. Integrate this. We're going to use our formula, okay? Negative 3 plus 1. What do you think that is? Look at your number line. You have negative 3 over here. You're adding 1, so you go to the right. Negative 2. So this becomes x to the negative 2 over negative 2, and don't forget your plus c. How do you simplify this? Well, you don't want the negative 2 over negative 2 here, so I could take that negative 2, and we're going to simplify it for now. Later on, we won't have to. And you just push it where? Back to the bottom. And you can't leave the top empty. You need a placeholder, so you put a 1 there. So you got 1 over 2x squared. I just took the negative, dragged it out front. If you want to leave this as regular 1 over negative 2x squared, you can. Negative 1 over 2x squared plus 6. Voila. Do problems 6 and 7. Go. Now let's go over them. Rewrite. Radical. So this is like a little 2 radical here, right? So it's x to the 1/2 dx. You should know that by your heart, by memorization. There we go. X to the 1/2 plus 1 over 1/2 plus 1. Now 1/2 plus 1 is the same as 1/2 plus 2 over 2. Okay, it's either 1.5 or 3/2. I like 3/2 better. It's always good to use these numbers better than mixed fractions. X to the 3/2 over 3/2. Now, remember when you have a fraction over a fraction, you keep the numerator on bottom of your fraction and your denominator goes to the top. So this becomes A over B over C equals A times C over B. It's a formula that we did multiple times, so you should be good with it by now, hopefully. So this guy kind of just comes up because when you divide by something, you're really just multiplying by the reciprocal. So you're multiplying this problem by 2/3. So 3 stays on bottom, 2 jumps to the top, and your answer is 2/3, because we reciprocate it, x to the 3/2 plus c. All right. You can also say 2x to the 3/2 over 3. All right. Or you can call this the square root of x cubed, if you want to do that. All right. I know some students rather write like that. Space. All right. Let's look at this one. What was the integral of sine? Just pull out your 2. Integral of sine, we said, was not cosine anymore. Negative cosine plus c. Negative times a 2 is a negative 2 cosine x plus c. There we go. You guys are off and running. Those are the 3 basic ones. Radicals, fractions, trig. Good? All right, do 8, 9, and 10. Ready? Toughest one, integral of dx. One that gets everyone every year. Did you get it? Well, what's before that dx? A 1. It's the same as the integral of 1 times dx. What's the integral of 1? Integral of a constant, right, is a constant times x plus c. So our constant here is 1. So it's 1x plus c, or x plus c. See? If this was a 6 dx, our answer would be 6x plus c. If this was 10 dx, it'd be 10x plus c. Negative 40 dx, it'd be negative 40x plus c. 1/2 dx, 1/2 x plus c. Blah, 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 blah. All right? This one, number 9. Because the derivative of 1 is indeed 0. All right, so integral of x dx plus the integral of 2 dx. So integral of x, we said it before, we're going to use our power rule. This is the same as x to the first power. The integral of x to the n is x to the n plus 1, n plus 1. Since this is a 1 right here, 1 plus 1 is 2. So you got x squared over 2 plus c1. All right, c1 because you get a constant from this. Integral of 2x, we just set it up here. Sorry, integral of 2 dx. 2x plus c2. Now remember, these letters right here are the things that have to match the functions you're looking for. What's c1 plus c2 though? We have 2 different constants. You guys know? Why does it just become a c? Because if you add a certain number to another certain number, it's a number, but this c could be any number. So it's whatever these 2 things are added together. All right? Not too bad, right? When you guys attempt problem 10. This is always just c. All right, so it doesn't really matter that you do c's here to the end. You're going to integrate each one of these individually. Pull out the 3, pull out the negative 5, pull out the nothing. Integral of x to the 4th. Put it through here. X to the 5th over 5. You multiply it by 3. 2. 2 plus 1 is 3. Now minus 5 times x to the 3rd minus 3. And x, this is a 1. We just set it over here. X squared over 2. And you add them all plus c. All right, now 3 times this is just 3/5 minus 5/3 plus 1/2. And you can pull these in front if you like, or you can leave them on top, 3x to the 5th over 5, so on, all right? I personally like writing it better like that. Good? All right, ready to move on? Let's move on to our next problem. Go. All right. Let's go over it. Integral of x, integral of 7 dx. X squared over 2 plus 7x plus c. Right here. X to the 5th plus 1. 5 plus 1 is 6. All right, so integral of that is x to the 6th over 6 plus x plus c. See? Becomes very easy the more you practice. Integrate each one's individually. Pull the constants out forward. And you don't technically have to write it like this. You can leave them in. This is just showing you how you multiply them by the end. X squared over 2. X cubed over 3. 2 divided by 2 is 1. 3 divided by 3 is 1. So it's x squared plus x cubed plus c. Easy. Only one that's difficult is number 14. This would have been your homework. X to the 3 halves plus 2 times x dx plus 1 dx. 3 halves plus 1 is 5 halves. Because 3 halves plus 1 is 3 halves, 3 over 2 plus 1 is 2 over 2. 3 over 2 plus 2 over 2. 3 plus 2 is 5, and the 2 stay the same. Now, plus 2 times x squared over 2 plus x plus c. Remember the reciprocal? You're multiplying this by 2/5, so the 2 jumps to the top. So this becomes, oh, there you go, a over b over c equals ac times b. So this becomes 2/5 times x to the 5 halves. 2 divided by 2 is just x squared plus x plus c. And that's it. Easy peasy. I want you guys to try problems 15 and 16. Ready? Integral of 13 dx minus x dx. 13x, x squared over 2 plus c. It's easy, right? X to the 4th over 4 minus 10 times x squared over 2 minus 3x. 10 divided by 2 is 5. So it's 1/4, plus c. 1/4 x to the 4th minus 5x squared minus 3x plus c. And just so you guys know, I'm just doing all these as we go. I haven't seen these in a while. Really not that bad. Once you get the hang of it, you can fly through these in your head. And that's what your goal is by the end of this. You're about halfway through. We'll see how you do by the end of the half. Do now 5.1. Make sure you put this on canvas. Ready? Pause. Play. All right, so we got 8 x cubed dx minus 9 x squared dx plus 4 dx. 4, 3, x. So 8 x to the 4th over 4 minus 9 x cubed over 3 plus 4x plus c. 8 divided by 4 is 2. 9 divided by 3 is 3 plus 4x plus c. Oh, there we go. Why did I do that? Never showed you these before. I kind of did. Square root of x. Rewrite it first. X to the 1/2. 1/2. What is this though? This is 1 over 2 x to the 1/2. So that's just x to the what? Radical x to the 1/2 plus, what's this become? 1 over radical x is x to the negative 1/2. So it's plus 1/2 x to the negative 1/2 dx. That's it. You're going to derive it in terms of x. 1/2 plus 1 is 3/2. Plus 1/2. Negative 1/2 plus 1. What's 1 minus 1/2? It's just 1/2. Reciprocal, 2/3. 1/2 divided by 1/2 is 1. So 2/3 x to the 3/2 plus x to the 1/2 plus c. 2/3 radical x cubed plus radical x plus c is also okay. Good? Awesome. Let's get into a new thing. Rewrite before integrating. This is what we just did, just to make sure you guys get the hang of it. So, the way you do this is I made some, through the years, I added in extra parts to my lessons just to make sure you guys understood it. So first step about this rewriting. You're going to rewrite it without the fraction. So now you got things divided by that. There is no such thing as a product rule. There is no such thing as a quotient rule with this. The only thing we're going to do later on is integration by substitution, which is really difficult, really time consuming, and you don't want to do it if you don't have to. It's not that hard, but... So you rewrite it without the fraction. Remember what to do if you have one function on bottom and two functions on top. You split it up. So we have x plus 1 over x to the 1/2. And what can we do with both these pieces? We could divide both of them by x to the 1/2. Or what you could do is you can use a distribution. Now remember before I said there is no product rule, right? So when I distribute this here, add the exponents, 1/2, oh here, distribute. What's 1/2 plus 1? Negative 1/2 plus 1, 1/2. And then this just becomes itself. X to the 1/2 plus x to the negative 1/2 dx. If you wanted to do it this way, 1 minus 1/2, you get x to the 1/2. 1 over x to the 1/2 is x to the negative 1/2. You could do it that way as well. You could just do division. I think it's easier to distribute. Once again, totally up to you. Step 3. After we get this, then we set it up. How do we set it up? We're going to integrate both those on their own. Integrate x to the 1/2 dx plus integrate x to the negative 1/2 dx. What do you think step 4 is? After you set it up, you integrate. 1/2 plus 1, negative 1/2 plus 1. 3/2 over 3/2 plus x to the 1/2 over 1/2 plus c. Step 5, always the last step, is always to simplify. Reciprocal, reciprocal. So you get 2/3 x to the 3/2 plus 2 over 1, or just 2 x to the 1/2. 2/3 square root of x cubed plus 2 square root of x plus c. And then you're done. All right? So always try to get rid of the stuff. No product rule, no quotient rule. Doesn't exist. Now, what I want you guys to do is try to solve these problems using 1, 2, 3 steps. Go. All right, problem number 18. Rewrite it. X to the, not 1/2, but 1/3. Whatever that number is, you put it to that 1 over that number. So integrate it. 1/3 plus 1. 1/3 plus 3 over 3 is 4 over 3. Reciprocal. 3/4 x to the 4/3 plus c. 3/4 cubed root of x to the 4th plus c. Rewrite this. The 1/4 stays the same. X squared on the denominator becomes x to the negative 2. Okay? If you want to pull the 1/4 out, you can. Doesn't matter. Integral of x to the negative 1/2. Negative 2 plus 1 is negative 1. That was 1/4 times x to the negative 1 divided by negative 1. Negative 1/4 x to the negative 1 plus c, or negative 1 over 4x plus c. Got it? I like to leave things like this now. I don't like my functions, my x's, inside the fraction. I like them all just raised to a power, albeit positive or negative. That's how they mostly do it in engineering as well. Ooh, x radical x. That's a tough one. Well, x is x to the first. Radical x is x to the 1/2, right? So, what is x times x to the 1/2? Remember, when you multiply variables, you add their exponents, so it's 1 plus 1/2. 1 over x to the 3/2. How can I rewrite this? Since it's in the denominator, it's x to the negative 3/2. All right? So all I did was rewrite this piece and get that. All right. Negative 3/2 plus 1, negative 3/2 plus 2 over 2 is a negative 1/2. Reciprocate that, you get 2 over 1 or a 2. Negative 2, x to the negative 1/2 plus c. Negative 2, x over square root of x plus c is also correct. Problem 21. First step is to distribute x to the 4th plus x. Integrate them both individually. X to the 5th over 5 plus x squared over 2. You can leave it like this if you want. A lot of people do. I like to put it as 1/5 x to the 5th plus 1/2 x squared plus c. All right. We all good? Right here, the 2 stays in the denominator. Don't move the 2. Don't move the 4. That's what a lot of people like to do. 1/2 x to the negative 3. Negative 3 plus 1 is negative 2. So 1/2 x to the negative 2 over negative 2. Now when you multiply across. 1 times this just remains the same. 2 times negative 2 is negative 4. So it's negative 1/4 x to the negative 2 plus c. All right, you got to remember your fraction rules. Square. You're squaring 3x. What is 3x times 3x? 9x squared. Now you're left with 1/9. X squared becomes x to the negative 2. All right, all the rules apply. 1/9 times x to the negative 1 over negative 1. Remember, you're adding. This just becomes negative. Negative 1/9 x to the negative 1 plus c. And there you go. You just integrated all those problems. Are you having fun? Bet you are. You betcha, right? All right. Mind you guys attempt then problems 24 through 27. I had to cheat with my original integral. Push it over a little bit. All right, so first thing you want to do is you want to rewrite, right? X to the negative 1/2 times 2. Negative 1/2 plus 1 is 1/2. Reciprocal of 1/2 is 2 over 1. 2 times 2 is 4. So it's 4x to the 1/2 plus c, or, 4 square root of x plus c. Here, you have to FOIL this. You have to use your rule. It's actually t squared plus 1 times t squared plus 1. Or you can just use the rule a squared plus 2ab plus b squared, but I know you guys don't like that rule. So you can FOIL t to the 4th plus t squared plus 1, t to the 4th plus 2t squared plus 1. And now you integrate each one individually. T to the 5th over 5, that's a 3. 2 times t to the 3rd over 3 plus t plus c, 2/3. T over 5 plus 5 plus 2t cubed over 3 plus t plus 3. Now, why did I write it like this? I just didn't have enough room. All right, normally I'd write 1/5 t 5th plus 2/3 t to the 3rd plus t plus c, but we're out of room. Like I said, you can write it in your way. You gotta do what you gotta do. I'll give you a hint. Divide. All right, so you're gonna divide each one of these by x squared. X cubed divided by x squared, 3 divided by x squared. Subtract 3 minus 2 is 1. 3x to the negative 2. All right, reducing exponents. 1 plus 1 is 2. Negative 2 plus 1 is negative 1. 3 over 2, negative 3. Okay, good. That was going to sneeze. X squared over 2, or 1/2 x squared minus 3x to the negative 1, or minus 3 over x plus c. All right. Problem 23. X to the 1/3 times x minus 4. 1 plus the 3rd, 3 over 3 plus 1 over 3 is 4 over 3, and this just becomes minus 4x to the 1/3. 4 over 3 plus 1 is 4 over 3 plus 3 over 3, which is 7 over 3, 4 over 3. So x to the 7/3 over 7/3 minus 4x to the 4/3 over 4/3. This becomes 3 over 7. This becomes 4 times 3/4, which is 12 over 4, which is, 12 divided by 4 is 3. Well, so you can cancel these 4's out with a 3 at the top. All right, just simple fraction work. Write it out, makes it easier to do. Got it? Almost done. All right, this one's kind of a silly slide. I skip it sometimes, but I'm going to do it anyway because I have all the time in the world. Find the particular solution for 28 through 40. So the graph right here, don't worry so much about that. Now, when it says find the particular solution, what they want you to do is find out what the actual value of c is. That's particular solution. So now we're going to use our integrations and then find c. So we're going to find it for 1. First step is to integrate 1 over x squared. So you rewrite it, and you do this, x to the negative 2 Negative 2 plus 1 is negative 1 over negative 1, right? Negative x to the negative 1 plus c. Now, what we're going to do next is we are going to find out what c is. Now we're given these two letters. This is your x and this is your f of x, or your x and your y. So what we could do is we're going to take our actual integrals. F of x equals negative 1 over x. I just rewrote it again, plus c. Step 2, plug in your f of x, which is 0. This is the key. And your x, which is the number that's in here for the f of x. F of x. That's how you can remember this thing's your x. And this is what f of x equals right here. So, f of x in this case equals 0, and x equals 1. So f of x, up there it is. F of x equals 0, and x equals 1. 0 equals negative 1 over 1 plus c. 1 over 1 is 1. 0 equals negative 1 plus c. Add 1 to both sides, and c equals 1. So now, at this particular point, at point 1, 0, okay, this point right here, we have this graph, okay? Your derivative of this graph right here is going to be, plug into f of x, negative 1 over x plus 1. That's your answer. So that graph right here is your answer. Got it? See what that was? Now, if I picked a point, say f of 2 equals 0, it'd be this graph right here. My c would be 2. If I pick this graph right here, 3, 0, okay? You can see 4, 0. I could pick a point that's 0, 1. I'd get this graph. I could pick a point that's, I don't know, this negative 2, 1 here is a 0, 3 halves, all right? I would get that graph right there. So depending on what your c is, gives you different graphs, right? Now, all we're going to do is, everything now is going to have 2 steps. The first step is to integrate. Because look at this, says for numbers 28 to 40. So there's a lot of number here. What you do as many as you can. Watch the video to see if you did it right. Do many more. Watch the video, and so on until you get it nasty. So I'll walk you through 29 now. So first step you want to do is rewrite this. X to the 2/3. Then you integrate it. 2/3 plus 1 is 5 over 3. Because 2 over 3 plus 3 over 3 is 5 over 3. Reciprocal of 3/5 is, reciprocal of 5/3 is 3/5. X to the 3/5 plus c. Ready? X, f of x. F of x is 6, x is 1. So you're going to plug that in. We know that 6, your f of x, equals 3/5 x to the 5/3 plus 1. 1 to anything is 1. So 6 equals 3/5 times 1 plus c. 3/5 times 1 is 3/5. 6 minus 3 over 5. Well, it's 6 and 2/5, right? I'm sorry, 5 and 2/5. I messed that up. All right, because it's technically 6 minus 0.6, which is 5.4, which is 5 and 2/5. See, I did that to try to save face. So that's my c. Plug it back in. F of x equals 3/5 x to the 5/3 plus 5 and 2/5. I particularly like to make this a 27 over 5, personally. That is also okay. 5.4 is okay. If you did like 0.6 x to the 5/3 plus 5.4, also okay. Right? Like 3 different ways to write it. Let's look at 30. Attempt to go. All right. X to the 3 over 4 plus 1. 3/4 plus 1. 3 plus 4 is 7/4 over 7/4 plus x plus c. Reciprocal of that is 4 over 7. X to the 7/4 plus x plus c. F of x is negative 3. So negative 3 equals 4 over 7 times 0 to the 7/4 plus 0 plus c. You have to plug in 0 for every x, for both x's. Okay? Got it? Anything times 0 is 0. So negative 3 equals 0 plus 0 plus c. So what does c equal? Negative 3. Plug it in. F of x equals 4 over 7 x to the 7/4 plus x plus negative 3, or just minus 3. There you go. That's it. Attempt the next 2. You guys are going to be experts at this. You got them? Both very similar. Rewrite x to the negative fifth. Negative 4 over negative 4 plus c. If you want to rewrite it, you can. You do not have to do this. You could leave it like this if you want to just use your calculator to solve for it. I particularly like to move it just because then I could do it in my head. In this case, f of x is negative 5, x is 1. All right? So negative 5 equals 1, negative 1 over 4 times 1 to the 4th plus c. Now, if I left this on top and put a 1 here, I know 1 to the negative 4th is also 1, so it doesn't really matter. You get the same answer. Negative 1 over 4 times 1, negative 1/4. Negative 5 plus 1/4. So you have negative 5, you're adding 1/4, so it gets closer to 0. So it's actually negative 4 3/4 plus c. F of x equals negative 1 over 4x to the 4th minus 4 3/4. Right? Or negative 1/4 x to the negative 4 minus 16 plus 3, 19 over 4. Like I said, multiple answers. You guys know what to do. Problem 32. X to the negative 6. Negative 6 plus 1 is negative 5. All right? If you want to rewrite like this again, you may. You may not if you don't want. F of x equals 11. X equals 0. Oh, this is a tougher one. This is why you want to rewrite it. 11 equals negative 1 over 5, 0 to the 5th plus c. 11 equals negative 1 over 5 times 0 plus c. 11 equals negative 1 over 0 plus c. What is negative 1 over 0 equal? 0? No. Uh-oh. It's undefined. So 11 equals undefined plus c. So does c equal 11? No. What does c equal? Cannot have a value. There is no value for c here. All right? Because a point at x equals 0 does not exist. Okay? Because in this case, there's no point at 0. Do you know why? Well, let's look back. If I take x and 0 and plug it into this equation, you get 1 over 0. So what actually is happening at the point 0? Do you guys remember from the graphing? If I plug 0 in here, denominator equals 0, you have a vertical asymptote. And if you have a vertical asymptote, you can't have an equation because there's nothing there, right? Ah, tricked you. I probably won't do that again. All right, let's try 33. All right, this one. I already give you a whole page for this. That's extra, right? Well, this is the one where you have to rewrite it. You have x to the negative, x to the 1/2 on top. So what you can do is you can either turn this to x to the negative 1/2 and distribute it to both of these, or I just like to divide them both by x to the 1/2. 1 minus 1/2 is x to the negative 1/2. Sorry, 1 minus 1/2 is x to the positive 1/2. 6 divided by x to the 1/2 is x to the negative 1/2. Derive both of those. 1/2 plus 1 is 3/2. X to the 3/2 over 3/2 plus 6 times x to the 1/2 over 1/2 plus c. Reciprocal, reciprocal. 2/3, 2 times 6 is 12. All right. Now, f of x is 4, x is 1. We got a lot of stuff to plug in here. So we're going to do 4 equals 2/3, 1 to the 3/2 plus 12, 1 to the 1/2 plus c. Now you're going to see this is easy because 1 to anything is 1. 4 times 2/3 times 1 plus 12 times 1 plus c. These are both the same. They stay. 2/3 plus 12 is 12 and 2/3. All right. You could say also 38 over 3. 4 minus 12 and 2/3. All right. 4 minus 12 is negative 8 and 2/3. Subtract an extra 2/3 equals c. 2/3 x to the 3/2 plus 12 x to the 1/2 minus, you can say 26 over 3 or 8 and 2/3. I like writing it mixed numbers, or the numbers from the same thing, but a lot of students like it this way better. Whatever you want, both same answer. 34. Almost there. Good. Divide everything by x to the 4th. 2 minus 4 is negative 2. 1 minus 4 is negative 3. Negative 4. Derive. Negative 1, negative 2, negative 3. This becomes negative x to negative 1. 2 divided by negative 2 is negative. Negative 3 divided by negative 3 is a positive. So Comes out pretty nice, right? F of x is negative 3, x is 2. Negative 3 equals negative 2 to the negative 1 minus 2 to the negative 2 plus 2 to the negative 3. If you want to make these 1 over 2 minus 1 over 2 squared minus 1 over 2 to the 8th, you may as well. Oh, third. Why did I say 8? I think it's easier that way. But you don't have to. You can do it all, just chug it right into a calculator. 2, 4. 4 times 2 is 8. All right. Negative 1/2 minus 1/4 plus 1/8. Okay. In case you forgot how to do this, if you want to do this just in your head, this becomes 2 over 8. This becomes 4 over 8. Negative 4 minus 2 is negative 6 over 8. Plus 1 over 8 is 5 over 8. Negative 5 over 8. Because you have to get a common denominator when you add fractions. Negative 3 plus 5 over 8 is negative 2 and 3/8, as you see. Bam, put it right back in. Negative x to negative 1, minus x to negative 2, plus x to negative 3, minus 2 and 3/8. If you want to write it like 1 over x squared, 1 over x cubed, this also acceptable. All right. Awesome. 35, 36. Easier problems. Almost there, almost there, almost there. All right. First step is to FOIL. 3x squared minus 2x plus 3x minus 2. Negative 3x plus 2x is minus x. And now you integrate them all. 3 times x to the third over 3 is x to the third. X squared over 2 minus 2x plus c. Now this is 3 times x to the third divided by 3. That's why there's no number there. 3 divided by 3 is 1. Negative 5 equals 0 times all that. Notice this becomes 0. 0 and 0. There's no zeros in the denominator, therefore there's no undefineds. Negative 5 is your c, and there's your answer. X cubed plus x squared over 2 minus 2x minus 5. See that? FOIL. Or you could do, what's that? A squared plus 2ab plus b squared. 4t to the 4th. 2t squared is a negative t squared. We have 2 of them. Negative 1 times negative 1 is 1. All right. Or you could do 2t to the second power minus 1 times 2t to the second power minus 1. And FOIL it. Whatever. Float your boat. 4 times t to the 5th over 5 minus 4 times t to the 3rd over 3 plus t plus c. 4/5, 4/3. All right. What do we got here? We got a negative 1 for our x, our t. All right. And we got a 10 for that. Negative 1 to the 5th power is negative 1. Negative 1 to the 3rd power is negative 1. And negative 1 by itself is negative 1. All right. If these were even exponents, it would turn into positive. So you got minus 4/5 plus 4/3 minus 1 plus c. All right, this becomes, what we have to use, 15. Negative 12 over 15 plus 20 over 15, which is 8 over 15, minus 15 over 15. So let's see if I get this right. 8 minus 15 is negative 7 over 15. Oh, look at that. Mental math. Because you want these all to be 15s. So you have to multiply this by 3 over 3, 5 over 5, 15 over 15. 10 minus 7 over 15 is 9 and 8/15. Oh wait, add 7/15. Ah, got the hard part right, you got the easy part wrong. Add 7 over 15, so you get 10 and 7/15. Boom, 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 plus 10 and 7/15. Alright? Be careful, don't make mistakes like me. Alright, 37. You have to distribute, distribute. Oh no. Alright. Y squared times y to the 1/2. So that's 4 over 2 plus 1 over 2 is 5 over 2. That's how you get that. 5 over 2 plus 1 is 7 over 2. Divided by 7 over 2. Reciprocal of 7 over 2 is 2 sevenths. Y to the 7/2 plus c. Alright. Alright, let's see. 12 equals 2 sevenths. 2 times the 2 sevenths plus c. I would just type this in the calculator. All right, you get 3.2 eventually. 2 to the, in parentheses, or actually just put this as 3.5. 2 to the 3.5, or 2 in parentheses, 7 divided by 2, close parentheses. That gives you 11.31 times 2 divided by 7 gives you about 3.2. Subtract that from 12, you get about 8.8, and then you put it there. Good. Distribute the t squared. T squared plus 3, 1 plus 2 is 3. This becomes t cubed over 3. 3 times t to the 4th over 4. 3/4. X is 0, f of x is negative 1/2. So you get negative 1/2, 0 and 0, c equals negative 1/2. 1/3 t to the cubed plus 3/4 t squared minus 1/2. Awesome. 2 more slides. Oh, these are the easy ones. What's the integral of dx? This is how we started this. Do you remember? Just x. Right? Plus c. Wait a second. F of x is negative 51 equals 24 plus c. Negative 51 minus 24. Negative 75. So your answer is just 75. Oops, subtracted from x. I saved myself there. Integral 14. 14x. Oh, dt. Since it's in terms of t, 14t. Whatever letter it's in terms of, that's what letter goes here. I wasn't paying attention. F of t is 0. T equals negative 5. So 0 equals 14 times negative 5 plus c. 0 equals negative 70 plus c. C equals 70. 14t plus 70. Ready for the last problem? This lesson went longer than I thought. Oh, this is the trig stuff that everyone loves. So how can we rewrite that before integrating? Sine over, well, cosine squared x becomes 2 cosine x's. Do we know what sine over cosine is? Tan. So is there a function for tan x, secant x? Yeah. The answer is secant x plus c. You have to go look back at your trig function sheet. We know the derivative of cosine is positive sine. We know the derivative of sine is negative cosine. Whoops. So 5 times sine x plus 4 times negative cosine x plus c. 5 sine x minus 4 cosine x plus c. Okay. Go back to the original page where I showed you all the original integrals of tangential functions, right? Not tangential. Trigonometric. Regular integral, trig integral. T to the 3rd over 3 minus sine t plus c. There you go. Oh, look at these, d theta. Integral of secant squared is tan. Integral of negative sine is negative cosine. Minus a negative is tan theta plus cosine theta plus c. 45. Ready? Secant tan times tan is secant tan. Secant times negative secant is secant squared. So you're going to integrate this. Is there one for secant tan? Yes, there is. Is there one for secant squared? Yes, there is. Since you're doing y, make sure they both have y's. Yes, they do. Secant, the derivative of secant y tan y is secant y. Derivative of secant squared is tan plus c. And there you go. That is the entire lesson on integrating. Now, hopefully you guys all get this. If you don't get this, what we're going to do is we are going to make sure that we get, here, I'll put this on just so you have something to look at. We're going to go over this a little bit more. You take a test on it. You guys are going to get good grades on your test, and you're going to enjoy it. All right? So if there's any questions, please email me. All right? I'll try to explain it better. All right? Goodbye.